Hello dear students, welcome to the discussion NCERT line by line questions. Today we discuss the chapter number 8, Electromagnetic Waves. It's a very simple chapter. We can move into the questions. 1. The correct order of arrangement of electromagnetic waves according to their frequency is. See, which one has the greatest frequency out of these? Gamma rays having greatest frequency, okay. Then microwaves, no. Ultraviolet, then microwaves, radio waves. Out of the given 4 electromagnetic waves, gamma, ultraviolet, micro and radio waves, answer is option 4. Good? Yes. Next one. The electromagnetic radiations used in radar system. In radar system, out of this, the one which is used is microwaves. Okay, uses of electromagnetic waves. Number 3, microwaves oven works on the principle of giving the rotational energy to water molecules and also giving the vibrational energy to water molecules. Okay, the rotational energy and the vibrational energy to the water molecules, and it is heated. So this is both 1 and 2 are the correct options in the case of microwaves oven. Okay, the next one. The RMS value of electric field of light coming from sun is 400 Newton per Coulomb. RMS value of the electric field ERMS is equal to 400 Newton per Coulomb. Okay, 400 Newton per Coulomb. Okay. Then, total energy density of electromagnetic waves is dash. Total energy density. Okay. The energy density contained in electric field is half epsilon naught ERMS square. Okay, and the energy density contained in the magnetic field is half. Okay, instead of epsilon 0 here it is 1 by mu 0. Okay, instead of ERMS here it is BRMS square. Okay. Yes, but it is proved that this result is also equal to this one. Both of these quantities are equal. So this is also equal to half epsilon naught ERMS square. Clear? Means the total energy density of the electromagnetic waves equal to this plus this. This plus this means this plus this. Half into epsilon 0 ERMS square into 2. Twice of these quantities. So the total energy density, see this is actually energy density, no? Energy density, energy divided by volume, that is energy density. Okay, these two quantities are not energy but they are energy density. Okay, so the total energy density is equal to sum of these two, which is epsilon naught ERMS square. Okay, this is equal to 8.854 into 10 to the power minus 12 into, what is ERMS value is 400 square. 400 square. Clear? Yes. 4 square is 16. 10 power 2 whole square is 10 power 4. So it is 8.854 into 16 into 10 power 4 into 10 power minus 12 is 10 power minus 8. 10 raised to minus 8. Clear? So what will be this value? This value is equal to this value almost, see, 90, then this is almost 144 in that range. Okay, 144 or 140 in that range. 140 into 10 power minus 8 means 1.4 into 10 power minus 6. What about this one? 1.42 into 10 power minus 6 joule per meter square. You know, energy density means energy per volume. So, joule per meter cube is a SI unit. Understood? So, the answer is option 1. Clear? Good. The next one. Cellular phones use radio waves to transmit voice communication in ultra high frequency bands. In ultra high frequency bands, the voice is transmitted. Voice is transmitted in very high frequency band. Direct one. Then, which of the following is not an electromagnetic wave? First one, heat rays. Actually, these are infrared radiation. So, this is heat wave. X-rays are electromagnetic waves. Then, gamma rays. Here, there is gamma is there, just missed. Gamma rays are electromagnetic waves. Then, beta rays are not electromagnetic waves. So, this is the answer of that particular question. Okay. Yes. Now, which among the following is incorrect? First one, wavelength of X-rays can range from 10 nanometer to 10 power minus 4 nanometer. Okay, this is correct one. 10 nanometer to 10 power minus 4 nanometer. X-rays are used in the treatment of certain form of cancer. That is also true. Okay, X-rays are produced by bombarding a metal target by high energy electrons. That is also true. And the fourth one, X-rays are used to observe growth of crops. This is incorrect. Okay, so the answer is option 4. Good. Next one, which among the following statement may be incorrect? 1. Infrared detectors are used in Earth satellites. This is true. In Earth satellites, infrared detectors are used. Then, electronic devices emit infrared radiations and are used in remote switches. In remote switches, electronic devices are used which are producing infrared radiations. Okay. C or 3. UV lamps are used in physical therapy. It is incorrect. Actually, infrared radiations are used in physical therapy. Okay, so that is incorrect. Then visible range of many insects extend well into ultraviolet waves. Many of the insects can view ultraviolet waves. So the answer is option C. Okay, next. The instantaneous magnitudes of electric field E and magnetic field B vectors in electromagnetic wave propagating in vacuum are related as. See, the instantaneous value of electric field intensity and magnetic field intensity are related as C is equal to E by B in vacuum. In another medium, that will be V is equal to E by B. Okay, C is equal to E divided by B. The ratio of electric field intensity to magnetic field intensity is the speed of light in that particular medium. In vacuum, it is C, which is 3 into 10 power 8 meter per second. So, E is equal to CB. The answer is option B. Right? Yes. The next one, a plane electromagnetic wave E is equal to 100 into sine of 5 into 10 power 8 t plus 3x. Volt per meter is propagating through a medium. The refractive index of the medium is, here the instantaneous value is given as 100, that is the peak value, then sine of omega t, in this way we can write, plus kx. In that way, a general formula for the variation of electric field intensity. Comparing this with the given data, we understand omega is equal to 5 into 10 raised to 8. 5 into 10 raised to 8 meter per rad per second. That is the SI unit of omega, you know. And K value is, see, the wave number K is equal to 3. Okay, wave number K is equal to 3. Meter inverse is SI unit, you know, meter inverse. See, wave number is meter inverse the SI unit. See, this one, this quantity is angle 3x, it has no unit. 3x has no unit means the unit of this K is inverse of x, that is meter inverse. Good. Now, what is the question? The refractive index of the medium is, the refractive index of a medium is N is equal to C divided by V. Clear? The ratio of speed of light in vacuum to the speed of light in that particular medium, that is the refractive index of that medium, C by V. C value we already know, 3 into 10 power 8. Then we should get V, the speed of light in that particular medium. Okay, we have a formula for the speed of light. If you obtain omega and k, that V is equal to omega by k. That's it. The speed of a wave in a medium is omega divided by k. Okay, then it is very direct. Omega is equal to 5 into 10 power 8 divided by k is 3. Okay, then place it. 3 into 10 power 8 divided by 5 by 3 into 10 raised to 8. Okay, 10 power 8 is cancelled. This 3 goes to the numerator. 3 into 3, 9. 9 divided by 5. Okay, 9 divided by 5. Clear? It is 1.8. Okay, refractive index has no SI unit. Is the ratio of similar quantities, speed by speed. So, refractive index is unitless and dimensionless. The answer of the question is 1.8, third option. Clear? Yes. Moving to the next one. Light with energy flux 1.2 watt per meter square. It is also the intensity. Energy flux. See, power divided by area. Okay. Otherwise, energy per unit area in unit time. That is also called intensity or flux also we can say. You can write the intensity. This quantity is also called intensity. 1.2 watt per meter square. Okay, this much intense is the light. It is falling on a non-reflecting surface at normal incidence. Non-reflecting surface at normal incidence. Okay. The pressure on the plate is, what is the pressure? Pressure, how much pressure this electromagnetic wave acts on the plate is asked one. Okay. We know pressure is equal to force divided by area. Force divided by area, pressure is equal to. Okay. Now, force is equal to dP by dt. Rate of change of momentum. That is the force. Okay. Divided by area is already there. Okay. Yes. Then, what about momentum? See, the momentum exerted by the electromagnetic wave is, momentum exerted by the electromagnetic wave is, see, energy divided by C. Energy, this U is not energy density, it is simply energy. Okay, we can write E also here, but then it will be confusing because this already given electric field here already. We are mentioning electric field in the previous question also. So, it just take this formula as the momentum of the electromagnetic wave is energy divided by speed of light. Yes. Then what will be dP by dt? dP by dt is equal to du divided by c dt. Du divided by c dt. Clear? Okay. Then what about this pressure? See, this pressure is equal to dP by dt by area. Then this should be divided by area. du divided by c dt divided by area. Good. Okay. Now you just check. What about this one? What is du by dt by area? This is nothing but the intensity. This one. This quantity, you know. This quantity du by dt by area. This is the intensity. Okay. Intensity. Wave intensity. That is the energy divided by time divided by area. Okay. That is the intensity. Clear? So, the pressure exerted by the electromagnetic wave is I by C. Intensity by C. You can study this formula. Intensity is given 1.2 in SI system and C value 3.3 into 10 power 8. So, the pressure is equal to 1.2 divided by 3 into 10 raised to 8. Good. Okay, this one we can write 0.3 into 10 power minus 9. 0.3 into 10 power minus 9. Okay, 1.2 divided by 0.3, it is 4. Okay, 4 into, okay, 10 power, here it is 10 power 9. Yes, 0.3 into 10 power 9, it is to the numerator. Then it becomes 10 power minus 9. Clear? And the SI unit of pressure is Pascal or Newton per meter square. Both are same. Newton per meter square or Pascal. Here in the options, Newton per meter square only. Good. So 4 into 10 power minus 9 Newton per meter square. It is answer C. Okay? Good. The next one. What is the peak electric field produced by the radiations coming from 100-watt bulb at a distance 3 meter? Assuming that bulb is point source, you assume the bulb as point source with efficiency of 2.5%. With an efficiency of 2.5%. Good. What we have to calculate is the peak value of electric field. See, the peak value of electric field is, I can write E naught, the peak value of electric field. It is equal to √2 times of ERMS. Okay, √2 times of ERMS. This is the first equation I am writing. Okay, and ERMS value we can obtain from the given data here. The power is 100 watt. Actually, the power of the source is 100 watt, but its efficiency is 2.5%. Then how much power is getting for the surface? Here, you consider the bulb as a point source. This is the bulb. Okay, this is the lamp, or this is the source. Okay, point source. And there is a surface at 3 meter distance away. Okay, what the question is, electric field produced by this radiation coming from this bulb at a distance 3 meter. At a distance 3 meter, you imagine a spherical surface. Okay, how much power is reaching to this spherical surface? How much power is reaching is the 2.5% of the power produced by the bulb. That much power is reaching here. Clear? Okay. Then see, what is the area of this one? The area of this one is 4 pi r square. This sphere, you know, imagine the sphere. What is the area is 4 pi r square. Okay. Then we have the intensity. See, the intensity. What is the intensity is equal to? Intensity is equal to the energy divided by time, or the energy du by dt, then divided by area. Okay, this much is the intensity coming. Clear? Yes. And what about the du by dt? Du by dt is the power, energy by time. That is the power reaching there. And area, I told you, 4 pi r square. Clear? And this is the intensity. Clear? And what is, you can connect intensity and ERMS value. I will connect it. Just wait. No, this one is, how much it is? Du by dt is the power there. Power of the bulb is 100 watt. Okay. Then 2.5% of this value only reaching there. So 100 into 2.5%. Okay. Yes. Divide by area. Area is 1 by 4 pi into r square. R square is 9. Clear? Yes. 100 is cancelled. Then we get, this is 2.5 divided by 4 into 9, 36 pi. Clear? This much intensity is reaching to this particular sphere, which is at a distance of 3 meter away, and its SI unit is watt per meter square. Watt per meter square. Okay. Yes. Then what about the energy density? The equation of energy density contained in the electric field. The energy density contained in the electric field is, I may write here, energy density. Energy density is equal to, that is equal to half into epsilon naught into ERMS square. Okay. This is the energy per unit volume. Energy per unit volume. Okay. If you consider a particular region, for simplicity, I am considering a cylindrical region. Okay. A cylindrical region of length L and having cross-sectional area A. And electromagnetic waves are passing through this region, suppose. Okay. Then the energy per unit volume of the surface is the energy contained in electric field region is half epsilon 0 E RMS square. Okay, half epsilon 0 E RMS square. See, that energy density, this half into epsilon 0 E RMS square. Okay, this is the energy per unit volume. Energy per unit volume, clear. Then this I am writing, this is the energy U divided by the total volume. Okay, total volume is AL. Total volume is AL. Clear? Yes. Yes. Energy per unit volume. This is the energy density. Clear? Yes. Then suppose the waves are passing with a speed c in a time interval t. The waves are passing with a speed c in a time interval t. Then we can connect this expression as L is equal to Ct. L is equal to Ct. Then I can write here U divided by A into, instead of L, I can write Ct. Now you clearly observe what this is. U by T, that is power, divided by area, that is intensity. Clearly, U by T is power, power by area is intensity. So this value is I by C. You understood it? Half into epsilon naught into E RMS square is equal to I by C. I by C. So what about the intensity? The intensity value is equal to half into epsilon naught E RMS square into C. This is the intensity. This formula you can write. Okay. The intensity. Half epsilon 0 E RMS square into C. This formula is possible for intensity. Clear? Now listen. What is the intensity value here? The intensity value from the question is 2.5 divided by 36 pi. 2.5 divided by 36 pi. You put here. 2.5 divided by 36 pi is equal to half into epsilon 0 E RMS square into C. Now listen. From this, we get E RMS value. Epsilon 0 we know. C value we know. So from this, we get E RMS value. From E RMS value, we get E naught. Okay. From E RMS value, we find E naught. What is this? From E RMS values. This is E naught is equal to root 2 times of E RMS. Is that clear? Is that clear? From this expression while solving, we get E RMS value. By putting this E RMS value here, you get E naught. And what is the peak electric field is asked in the question. Okay, clear? Is that clear? Simply, this I is equal to half into epsilon naught into E RMS square into C. Therefore, E RMS is equal to, I can write here, E RMS is equal to root of 2I divided by epsilon naught C. 2I divided by epsilon naught C. Okay. Therefore, E naught is equal to, I may write here, the peak value E naught is equal to root 2 times of E RMS. Okay. When you multiply this one with root 2, okay, then this root 2 into root 2, that is 2. 2 into then root of I divided by epsilon 0 C. Now everything is okay. I value is just here. Epsilon naught value we know. C value we know. When we put all these, we get the answer is option 4. I hope you understood clearly. The formula, the important formula one is this one. Intensity in terms of E RMS and C. Okay. Very good. Moving to the next one. In electromagnetic wave, if peak value of magnetic field is, I am writing B naught is equal to 1.4 into 10 power minus 8 Tesla. Then RMS value of electric field will be, what is the RMS value of electric field? This question. Okay, we have the relation connecting magnetic field and electric field as C is equal to ERMS divided by BRMS. C is equal to ERMS by BRMS. Then ERMS is equal to RMS value of electric field is equal to BRMS into C. Okay. BRMS. How we get BRMS from B naught? It is B naught divided by root 2. Clear? Into C. Okay. B naught is how much given? 1.4 into 10 power minus 8. Okay. Divided by root 2 into C. 3 into 10 power 8. Good. Now listen. 1.4 and root 2 cancelled. Root 2 is almost 1.4. These two cancelled. Clear. 10 power minus 8 into 10 power 8 becomes 1 and the answer is approximately 3. Approximately 3 is this is the answer, option B. Okay? Very good. 14th. Light with an energy flux of 6 watt per centimeter square. Energy flux is also known as the intensity and it is 6 watt per centimeter square. Okay, not meter square, remember it. Falls on a non-reflecting surface at normal incidence. If surface has an area of 50 centimeter square, the area given in the question is 50 centimeter square. Okay. What is total momentum transferred in 1 minute to the surface? How much is the total momentum transfer in 1 minute? Okay. In the case of complete absorption. In the case of complete absorption, what is the total momentum transferred? You are having energy density and the area of the surface. Clear? Yes. Momentum transferred. What is the momentum transferred? P is equal to U by C. Momentum transferred is P is equal to U by C. Okay. Then here, C value is known value. And what about U? U we can calculate from this. Clear? What about intensity? I is equal to U divided by area into time. Okay. Then what is the energy value? U is equal to I into area into time. Clear? Put here. This is intensity into area into time divided by C. Now everything perfect. Intensity given how much? 6 watt per centimeter square. Centimeter square we are not converting because this area is also given in centimeter square. Clear? So this is 6 into 50. Clear? 6 watt per centimeter square and 50 centimeter square. So centimeter square will be cancelled. Clear? Into minute. Minute in 1 minute. Okay, they are asking in 1 minute. 1 minute means 60 seconds to the SI unit. Divided by C into 10 power 8 meter per second. Okay. 6 by 3, that is 2. Okay. 2, 1 0, another 0, 10 raised to 2 and 10 power 8, then this will be 10 power 6. Okay. 2 into 5, that is 10, then this will be 10 power 5. Okay. Then 6, what this is? 6 into 10 raised to minus 5 is the answer. 6 into 10 raised to minus 5 is the answer. Kilogram meter per second. That is the SI unit of momentum. SI unit of linear momentum is kilogram meter per second. 6 into 10 raised to minus 5. Very easy calculation. Okay. Moving to the next one. The electric field component propagating along x-axis is given as. Okay. The electric field propagating along x-axis. The energy is propagating along x-axis. Then the vibration of the field will be along y or z. And here it is given along y. Ey is equal to 30 into sine of 4.5 into 10 power 2x plus 1.5 into 10 power 11t. Good. Volt per meter, that is in SI unit. The frequency of propagating wave is. The frequency of the propagating wave is asked. From this, we get the omega value. Okay, we have the standard formula Ey is equal to E naught into sine of kx plus omega t. So we get the omega value 1.5 into 10 power 11 rad per second, isn't it? And what is omega? Omega is 2 pi nu. 2 pi nu is 1.5 into 10 power 11 rad per second. From this directly we get frequency 1.5 into 10 raised to 11 divided by 2 pi. Clear? Yes. 2 pi is 6 point something. Okay. 1.5 divided by 6 point something is 1 by 4. It is just comparison. 1 by 4. 1 by 4 is 0.25. 0.25 into 10 raised to 11. 0.25 into 10 raised to 11. Then 25 in that range. 25 in that range. Here this is the answer. See? Okay. 0.25 is just a comparison. So I am writing it is 0.239. Okay. Because here it is. Into 10 raised to 11. 10 raised to 11. Okay. Taking 2 zeros or 100 here. Then it becomes 23.9 into 10 raised to 9 hertz. Clear? What is 10 raised to 9 hertz is gigahertz. Clear? 23.9 gigahertz. Clear? It's very simple. Okay. Okay. Good. Okay. Moving to the next one. A capacitor is made of 2 circular plates, each of radius 7 centimeter and separated by 2 centimeter. A capacitor is made of 2 circular plates. These plates are having radius 7 centimeter and the plates are separated by 2 centimeter. Okay. The capacitor is being charged by an external source. Okay. The charging current is constant and equal to 0.2 ampere. Okay. Current. Okay. This is not intensity. Now we are writing is current is equal to 0.2 ampere. Good. What is the rate of change of potential difference between the plates? The rate of change of potential difference, that is dV by dt, is asked. Clear? Okay. We have the equation of capacitance is epsilon naught A by D. Epsilon naught A divided by D. Capacitance is equal to. Clear? See, A can be calculated because radius is given and the separation D is already given 2 centimeter. Clear? Okay. And we get charge from this I is equal to. Okay. What about I is equal to, I am writing this I is equal to dq by dt. I is equal to dq by dt. And we have Q is equal to CV. Remember the formula. Q is equal to CV. Yes. Then current I is equal to d of CV divided by dt. Okay. C is constant, take it outside. C into dV by dt. Very good. C into dV by dt. This is the current. Okay. Then dV by dt is asked, you know. dV by dt is I by C. dV by dt is I by C. Okay. dV by dt is equal to current divided by capacitance. Okay. Current divided by capacitance. Clear. Capacitance can be calculated epsilon 0 A by D. Clear. So this is equal to, current is given here. The value of current in the question 0.2. Clear. 0.2 divided by C is equal to epsilon naught A divided by D. Okay. 0.2 into separation is 2 centimeter divided by epsilon naught is 8.854 into 10 power minus 12. Okay. Area of the plate is pi r square. Pi into radius is 7 centimeter. 7 centimeter, 7 square into 10 power minus 4. That is centimeter square into meter square. Okay. This is to be calculated. Okay. Very easily done. Actually, this is epsilon naught. And here is a pi is here. So, if we multiply with 4 here, then here also we should multiply with 4. Then I can write this is 9 into 10 raised to 9 into 4. Now, 8.854 is done, this one is done, and this pi is also done. Okay, you understood that? 1 divided by 4 pi epsilon 0. Then 1 4 also should be here. So 9 into 10 power 9 into 4. Okay, the remaining. 2 into 0.2 into 10 raised to minus 2. Okay, that is 2 into 10 power minus 3. 2 into 0.2 into 10 power minus 2. 2 into 0.2, that is 0.4 into 10 power minus 2. That is 4 into 10 power minus 3. Isn't it? 4 into 10 power minus 3. Divided by 7 square is 49. Okay. Into 10 power minus 4. Okay. 10 raised to 9 into 10 power minus 3 is 10 raised to 6. 10 raised to 6 divided by 10 raised to minus 4 is 10 raised to minus 2. 10 raised to minus 2. Okay. 4 into 4 is 16. Clear? 9 into 16 divided by 49 into 10 raised to minus 2. Okay. Then this is 144. 144 divided by 49 is just nearly 3. Just nearly 3. Nearly 3. Okay. Just nearly 3. Then what about this one is, and what is here the power of 10, you know. 10 power minus 2 also. Just nearly 3, then 10 power minus 2. 10 power minus 2. Okay. Then what the answer is? This is just greater than 3, no? This is 9 into 40. 9 into 16 is 90 plus 54. That is 144 divided by 49. Okay. Then it is just less than 3. It is just less than 3. Less than 3 is this one. Less than 3 is this one. Okay. So this option you change as 2.94 into 10 power minus 2. Okay. Yes. 2.94 into 10 power minus 2 volt per second. Volt per second. Okay. 10 power minus 2. Okay. 2.94. 2.94 into 10 power minus 2 volt per second. That's it. Okay. I think the calculation is very simple. See, these options are, some mistakes are in the options. So, this is the correct answer. Understood? Yes. Moving to the next one, 17th. See. A radio is tuned to station in the 30 megahertz to 54 megahertz. What is the corresponding wavelength band? Corresponding wavelength band. See, up to 1 megahertz it is AM. Up to 1 megahertz it is amplitude modulation. Okay. Then from 54 to 108, 54 to 108, in that range it is FM band. Clear? Then this region, you know, 30 to 54, that is short band. Short band. Okay. Short band. And this is very high frequency band. So the answer of our question is short band. Okay. Option C. Correct. 18th. Which among the following statement is incorrect in electromagnetic spectrum? Incorrect. First one. Long distance radio broadcasts use short waves. That is true. Long distance means should be much energetic. Much energetic means minimum wavelength. X-rays astronomy is possible from satellite orbiting Earth. X-rays astronomy is possible from satellite orbiting Earth. Okay. That is also true. You just read this and study it. Microwaves range from 400 nm to 0.6 nm. This is incorrect. See, actually microwaves, you know, this is gamma, then X, then ultraviolet, then visible, then infrared, microwaves, radio. Radio, okay? Radio waves. See, 400 nm is almost visible. 400 nanometer is visible wavelength. And the 0.6 nm, that is the wavelength is still reducing. Still reducing means frequency is increasing. So that will be in the ultraviolet range, not in the microwave range. Okay. So this wavelength range is not in the microwave range. It will be in the ultraviolet and X-ray range. X-ray range. So this is the incorrect statement. Snakes are sensitive to infrared waves. That is also true. So answer is option C. Okay. Yes. The next one. Correct match of column 1 with column 2 is infrared. Infrared radiation. Infrared radiation is produced by, see, this vibration of atoms and molecules. Okay. Radio waves are produced by rapid vibration of electrons in aerials. Radio waves. Okay. That is A to S, B to P. This is option A to S, B to P. Then light, that is, what is this? Q. Electrons in atoms emit light when they move from higher to lower energy level. Okay, light. Then microwave, klystron wall. Microwave produced by klystron wall. So the answer is option B. The second option is the correct answer. The final question is, find the incorrect statement among the following. Incorrect. First one, accelerated charged particles radiate electromagnetic waves. Electromagnetic waves are produced by accelerated charged particles. Then, visible radiations emitted by atoms is much longer in wavelength than atomic size. See, visible radiations emitted by atoms is, visible means in an average of 500 nanometer. Okay, and the atomic size is around 1 angstrom. Around 1 angstrom. So when we convert this into angstrom, we get 5000 angstrom. Okay, 5000 angstrom. So this is atomic size 1 angstrom and the visible radiation is 5000 times of this. 5000 times of this. So this one is also true. Visible radiations having much longer wavelength than atomic size. Then X-rays are emitted from heavy atoms. X-rays are emitted from heavy atoms, true. Heavy atoms, metallic atoms. Then radio waves are produced by atomic molecules. This is incorrect. Radio waves are not produced by atomic molecules. They are produced by, here rapid vibration of electrons in aerials, not by atomic molecules. So the answer of this question is option 4. Okay. These are the questions, dear students. Very easy questions. Okay. Study well. Keep up your good work. See you then.